Good morning, my dear students. So far in this chapter 4, atomic structure, we have studied Dalton's atomic theory, cathode rays, discovery of electron, J.J. Thomson's experiment, properties of cathode rays, properties of electrons, how the anode rays were invented by Goldstein, and with the help of these anode rays, how we could know about the positively charged particles, protons. Then we had seen the plum pudding atomic model. So far we are knowing that an atom, it is made up of electron and proton only. So far we are knowing nothing about neutron. But today so far we are knowing that an atom, it is made up of electron and proton. As it was stated by electron, it was given by J.J. Thomson, and proton by Goldstein. We are knowing nothing anymore. But today we will see, electron and proton. After this electron and proton, there will be some another thing. We will see it after 10 to 15 minutes. So now today we will start discovery of nucleus. What is discovery of nucleus? First of all, he was once again Lord Rutherford. Before we proceed this, we will do a few things. We would like to know alpha particles. What is alpha particles? What is alpha particles? We know that helium, its atomic number is 2 and mass number is 4. We have to do nothing with mass number. Atomic number is 2. It means helium has 2 protons and an atom has equal number of proton and electrons. So helium has 2 protons, means helium has 2 electrons also. Now this helium is neutral. When it loses 2 electrons, it becomes positive. We don't say the word positive. I am using wrong words just to make you understand. So after losing 2 electrons, it becomes positive, but not positive. We can write this one plus or 2 plus or plus 2. It will be wrong. We cannot write plus 2. We can write 2 plus or plus. This will be called helium 2 plus or helium doubly positively charged or double positively charged. It will be not said helium plus, but we will call it by helium double positively charged, and this helium double positively charged is your alpha particles. So now what is alpha particles? The doubly charged helium ion, and how it is formed? By losing 2 electrons from a neutral helium. So this doubly charged helium ion formed by losing 2 electrons from a neutral helium is called alpha particles. Another thing, your book is roughly thickness is what? You can see the thickness. What will be the thickness of a book? Approximately 1 centimeter. And how much pages it have? 250, 260. Just imagine 260, 250, and it is not 260, 250. If it is 250, the number of pages will be just half. Why? Here we count page number 57. Here is what? 57, 58. Actual number of pages will be how much? Just half. If it has 300 pages on both either side, means it is divided into 150 leaves. Now 150 leaves in 1 centimeter. So if we take 4 centimeter, how many leaves will be? Hardly 600 leaves. Not more than that. Now you imagine, take a 4 centimeter thickness of gold as Rutherford has taken. Now he divided into 1 lakh sheets. What a thin sheet it will be. It might have been a very thin and thin. So Rutherford has taken a very thin sheet. Here we will have a word foil, F-O-I-L, F-O-I-L, foil means sheet. So this is your gold sheet, gold foil. Its thickness was 4 centimeter. After beating and beating, now it was done the thickness. He took a gold foil of this much thickness, point or decimal or 0.00004 centimeters. Then he had thrown alpha particles. What is alpha particle, my dear friend? Just I had told you, it is doubly or double positively charged. What he found, these alpha rays or these alpha particle passed in straight line. During drawing there may be some zigzag position, line may not be straight, but they passed in straight line. But as soon as these particles came, this is the central part, this is the center of the atom. We know that an atom is spherical. Spherical means it is more or less round. If it is round, means it is more or less circular. Obviously it will have a center. So far we will call it center for our next few minutes. But the rays, while approaching towards the center, now started deflecting. As soon as it came close to the center, these rays started deflecting. These started deflecting. But as the rays went away from the center, the rate of deflection started decreasing, and going further away. Once again the rays started passing in straight line. They are passing in straight line. Then he also found one ray out of 10,000. 10,000 में एक रे. ऐसा हुआ बाबू कि one ray in 10,000, one ray in 10,000, it bounced back in the same direction. This led to think now why the positively charged, they were passing straight in line, but as these particles, these rays were approaching towards the center, they started deflecting, and exactly coming on the center, one ray is bounced back on the same direction. Since this experiment was done by throwing the alpha particles, therefore this experiment is also called as Rutherford atomic model or alpha particle scattering experiment. You can see here Lord Rutherford, who was New Zealand's scientist, directed a stream of alpha particles. What is alpha particles? Alpha particles is a doubly charged helium ion containing two protons and two neutrons. It is formed by how H2 He2 plus means helium ion is formed. It is formed by removing two electrons from helium atom. I had told you a few minutes before. So after he towards a thin 1 millionth of centimeter foil, just you can imagine, he selected a gold foil because it is very much flexible and soft to beat and to make thin sheet. So he wanted as thin a layer as possible, as thin as much it is possible. For this, gold was the most suitable. It is most malleable metal. We know what is malleable. Malleable means to make sheet by beating. So after throwing this experiment, what he observed, most of the alpha particle passed in a straight line. Most of the alpha particle passed in a straight line. Some alpha particles were slightly deflected from their path. Some were slightly deflected and some were highly deflected, and very few, nearly 1 in 10,000 alpha particles were either deflected with high angle or completely bounced back. This rays was going and came back. This led to think why it happened so. Ultimately, he came to know. He gave some observations. What was his observation? So far we were using term center. I had told you we will use this center, this place, this center for next few minutes. Now we will call it by another name. So what was his observation? Those observations are called as your Rutherford's atomic model. According to this Rutherford atomic model, the atom contains a large empty space. Why? If there is no large space, why these rays are passing in a straight line? Why after bending or deflecting passes from here? It means it has a large space. That's why most of the alpha particle pass through the metal foil without any deviation. Now, we had seen here as the rays were approaching towards the center. So far, once again, I am using word center instead of nucleus. In this point, we will use this center as, we will call this center as nucleus. What was the reason that while the rays approaching towards this center started deflecting? That means there is some positively charged particles. And later on he found that all the positively charged particles, protons, are here at the center, which we will call right now as nucleus. There is a positively charged mass at the center of the atom, which was termed as nucleus, in which the entire mass of atom is situated. I will make you understand why it is said entire mass. Therefore, the nucleus is the densest part of an atom. The electrical positive nature of nucleus is supported by fact that positively charged alpha particles approaching towards the nucleus, towards the we were using word center, now we will use nucleus, approaching towards nucleus were deflected. This proved that nucleus contains positively charged particles, protons. Now there was a word. Entire mass of atom is concentrated at nucleus. See, Babu. Now this center we will call it as nucleus. We know that an atom is made up of electron and protons only. Its mass is not zero, it is not zero, but supposed to be negligible, which is said as zero. It is negligible, mass is negligible, taken as almost zero. So only and protons, one proton has one unit mass or 1 AMU, just like the mass of hydrogen. So if an atom is made up of only electron and proton, if electron's mass is considered to be negligible or almost zero, that means it has the mass, an atom has the mass only the how many, the mass of protons. How many protons may be there? That many atomic mass unit, that much mass will be there. So since all the protons are here, therefore all the masses of an atom is present only at this nucleus, which is located at the central part of an atom. The size of nucleus is very small in the comparison of size of an atom. See, we had studied that if we take a stadium, just imagine a stadium. Don't go to a stadium. Take your playground in your school. How long it is? Now if this is your now school playground, it is your school playground. If it is your school playground, at the middle of the ground, at the center of the ground, if we put a cricket ball, how you will compare in terms of size? How many times the ground is bigger than a cricket ball? It is very and very small. Likewise, now this nucleus is very and very small in comparison of the atoms. Now electron revolve around the nucleus at large distances from each other and from nuclei in empty places. Now here is your nucleus and this is your orbits or cell. My dear friends, this is an imaginary line. This is an imaginary line in which the electrons rotates. This is called orbit or cell. These are called cell or orbits. The electron revolves around the... Now, an atom as a whole is electrically neutral. Why an atom is electrically neutral? Because, see Babu, proton has 1.602 into 10 to power minus 19 coulomb charge. An electron has also same charge, 1.602 into 10 to the power minus 19 coulomb. Both proton and electron have same charge. Same charge. What is the basic difference? Proton contains positive charge and this charge is called 1 unit charge. This is also called 1 unit charge, but electrons carry negative charge. So any atom has same number of protons and electrons. As a result, whatsoever may be the positive charge, same will be negative charge. So positive plus negative makes an atom electrically neutral. We had seen in our previous classes also. Electron revolve around the nucleus on a circular path known as orbit. We had seen it. The force of attraction between the negatively charged particles means electron and positively charged particles means they all are in the nucleus is counterbalanced by centrifugal force. Now what is centrifugal force? Suppose this is your house. Your house is constructed in this manner. It is circular. You are revolving in your house. You are revolving in your house. And here is your neighbor's house. If you sleep here, अगर गलती से आप गिर जाएंगे तो अपने घर के अंदर दौड़ रहे बाबू मैया तो कहाँ गिरेंगे? अपने घर में, ना कि पड़ोसी के घर में जाके गिरेंगे. If you are running on a circular path inside your house, by mistake if you sleep, you will fall down inside your house, not at the house of your neighbor. So, there is a force of attraction which is attracting you towards the center. I'm sure in the fourth chapter in physics, you might have studied centrifugal force and centripetal force. So what is centrifugal force? When an object is revolving on a circular path means there will be a center of force acts or a force tend to attract that moving object towards its center. That force is called your centrifugal force and it is a real force. Now if an object is moving on circular path, this will be the center. Here outside of circle, outside of the circle, if here is supposed a point A, here is a force of attraction which tends to attract this moving object towards itself, which will never happen. This is called centripetal force. So centripetal force is what? An imaginary force tending to attract an object moving on a circular path. Imaginary force is called your centripetal force and this one is your imaginary force. I am sure you might have studied in the chapter physics. So my dear students, these were the models given by Lord Rutherford after alpha scattering experiment. We must know these concepts. We may get some points. We may get questions even in terminal or board exam. What is alpha particle scattering experiment? Then we will do this one. And what is Rutherford atomic model? We have to elaborate this one. Now no need to write this one. So my dear students, it is for today. We will meet on next day. See you. Bye.